day, Bayaw. I'm here to give an example in fluid mechanics from chapter 7, fluid flow in pipes. Water flows through a 3 cm diameter pipe at 1.8 meter per second. Calculate the Reynolds number and find also the velocity required to give the same Reynolds number when the pipe is transporting air. For the water, the kinematic viscosity was 1.35 times 10 raised to negative 6 squared meter per second, and the density was 1000 kilogram per cubic meter. For air, those quantities were 16 times 10 raised to negative 6 squared meter per second and 1.19 kilogram per cubic meter. So the given in this problem are: the diameter is equal to 3 centimeter, which is equivalent to 0.03 meter. So the velocity of water is equal to 1.8 meter per second. The kinematic viscosity of water is equal to 1.35 times 10 raised to negative 6 squared meter per second. The density of water is equal to 1000 kilogram per cubic meter. The kinematic viscosity of air is equal to 16 times 10 raised to negative 6 squared meter per second. The density of air is equal to 1.19 kilogram per cubic meter. So find the velocity. Our solution. So to find the Reynolds number of water is equal to kinematic viscosity times the diameter over velocity. So Reynolds of water is equal to 1.8 meter per second times 0.03 meter over 1.35 times 10 raised to negative 6 squared meter per second. Simplify, so is equal to 40,000. Since Re of air is equal to Re of water is equal, so velocity times 0.03 meter over 16 times 10 raised to negative 6 squared meter per second is equal to 40,000. Simplify, so our velocity is equal to 21.33 meter per second.